In this lesson, we're going to practice more questions that involve calculating the slope of secant and tangent lines. So we're just going to start by reviewing some terminology. You can find the average rate of change between 2 points on the graph by finding the slope of the line connecting them. And this average rate of change is the slope of the secant line that we draw. So for something like y equals x squared minus x minus 2, if I want to find the slope of the secant line between x equals 2 and x equals 4, I start by figuring out what is y1 and what's y2. So y1 is going to be, we'll say, 2 squared minus 2 minus 2. So that gives us 4 minus 2 is 2, minus 2 is 0. So 2, 0 is the first point. And the next value, y2, is going to be 4 squared minus 4 minus 2. 16 minus 6 is 10. So the next value then, the next point that I know on the curve is 4, 10. And there's the 2 points I'm going to connect with my straight line. And I need to find the slope between those 2 points. So the slope of the secant line is just my slope formula, 10 minus 0 over 4 minus 2. That's 10 over 2, which is 5. So the slope of the secant line then, between x equals 2 and x equals 4, is 5. Okay, if I want to find the slope of the tangent line, you'll remember that that's the slope, the instantaneous slope, and that's going to instantaneous rate of change, and that's going to happen at only one point on the curve. So we need to find the slope of the tangent line that's touching just at 2, 0. So we've already found the x and y coordinate for the first point, 2, 0. And we need to pick some values that are close to 2 so that we can find some rates of change that are pretty close. So again, I'm allowed to go on the left side or the right side. I'm going to go on the right side of 2 and pick values like 2.1, 2.01, 2.001. So I'm going to set up a little chart here. So I'm going to have my interval. So my intervals are going to be x between 2 and 2.1, 2 and 2.01, and 2 and 2.001. And my change in y, I'm going to take the second y value, so y at x equals 2.1, and I'm going to subtract y when x is 2. And it's easy because we know y when x is 2 is just 0. So it's just going to actually be the y coordinate 2.1. So delta y is 0.31. When I put in 2.1, I get 0.31 for y, and the change is 0.31 minus 0. And then I'm going to do the same thing here. I'm going to take y at 2.01 minus y at 2, which is just 0. And I'm going to end up with 0.0301. And the last entry, I'm going to do y at 2.001 minus y at 2. Then I'm going to end up with 0.003001. And just remember, all I'm doing there is I'm just subtracting the y values that go along with the two x values in the first column. The change in x comes from the interval. So 0.1 is my first interval because it's going to be 2.1 minus 2. And then I'm looking for values of x that are 0.01 apart, and then values of x that are 0.01 apart. And the slope is just take the delta y, divide it by delta x. So 0.31 divided by 0.1 is 3.1. And then I have 3.01. And then I have 3.001. And we are looking for the limiting value of those slopes. As delta x goes to 0, the limiting value of the m's goes to 3. So the slope is 3 of the tangent. And again, I'm just looking at the pattern, not just the last value. The last value is kind of as close as you're going to get, but you're looking for the pattern of those values. The limiting value, the values are all going towards 3. So the last step says, find the equation of the tangent at 2, 0. So the last part is just putting it into y equals mx plus b. So I know that the m is 3 for my tangent, and I have to substitute in just the point I know. So 2, 0 is the nicest choice. You can use any point on the curve, not on the line, but on the curve. And so we would end up with 0 equals 3 times 2 plus b, and b ends up being negative 6. So your equation of the tangent at 2, 0 is y equals 3x minus 6. So that would be a line that has a slope of 3 and a y-intercept of negative 6, and it touches the curve only at the 1.20.